Okay, girls, this is 8D, conditional probability. Suppose that in a group of 18 bicycles, 9 have gears, 11 have suspension, and 5 have both gears and suspension. We want to illustrate this in a Venn diagram. So we know that the intersection, suspension, gears, suspension, we know the intersection is 5. So that's the first thing we should put down. Then, in gears, 9 have gears, so I need 4 more here to make up the 9. And 11 have suspension, so I need 6 here to make up the 11. Okay, so I've done that. How many of the bicycles have a suspension? How many of the bicycles that have a suspension also have gears? 5. Which areas of the Venn diagram are considered when answering that question? Well, the intersection, right? When two things have to happen at once. What would be the answer to the question in reverse? What's the probability that a bicycle will have a suspension given that it has gears? This is how this works. Given that it has gears becomes the denominator of this problem. So all the gears go under here, the number of gears. And the ones that also have a suspension go on top. So the probability of suspension given gears is 5 over 9. So here's kind of the rule of this, the big idea. The probability of event A occurring, given that B has occurred, you know what, I really want you to think of this. Okay, we'll use this in year 12, but for right now, you guys can use this. So B, if it's the probability of A given B, and if it's the probability of B given A, that's what this little line means, given, then it's the number in the intersection over the number in A. So the second part becomes that. They give you a little Venn diagram, but really let's do some examples. Okay, there we go. Consider the Venn diagram displaying A and B. So I want the probability of A, well that's 5 out of the total, which is 9. Now, the intersection, the probability of the intersection is 2 out of 9. Then it says find the probability of A given B. A given B. I'm just rewriting that so you know how to say it. The given part goes underneath. So given B. So in B there are 6 things. And the probability of the things that are in A that are also in that circle is 2. So 1/3. This is the probability of B given A. So the given is on the bottom, A, that's 5. And the things that are in B that are also in A, 2. That's that. It's pretty easy. Let's try this one. It says a group, of 15 hockey players at a game, 13 on the field, 17 on the bench, 5 played both. It says, give us a two-way table, okay? Okay, so we've got A, that they're on the field. I'm going to use an F, stuff that. I think it's easier to use F and bench, okay? So we got field and not field, whoops, and bench and not bench. Remember the two-way table. All right. So they say 5 people did both. But the total down here of field people has to be 13. So this must be 8. And the total of bench people is 7. So this must be 2. And there's nobody that didn't do anything. Or at least that's what we see. So I know if I add that up, if I do my totals here, I get 7 and 13 and 2 and 8. And these both add to 15. So I'm happy. Okay, my table works out. Okay, it says represent the information. We've done that. Find the probability that a person only sat on the bench. Okay, only sat on the bench is not these people, it's these people, right? 2, so bench not fielded, 2 out of 15. That's B. C says find the probability the person sat on the bench given that they played the field. So this is where I am. They played the field. So 13's on the bottom, and all those people that and then D says find the probability that a person played on the field given that they sat on the bench. Here's the benchers. So 7's the denominator, and the ones that played on the field, 5 out of 7. So I don't think this is very hard. Give it a good go. I'll give you some problems in class.